go from here. Okay, we'll go from current slide 2. Okay, now before we get going on this, Cengage has been sending me the class keys here, there, one, somewhere really spaced out. Did I get y'all your class keys earlier, or was that over the weekend for the book? It was over the weekend. So, huh? Yeah. Okay. All right. So let me follow that up here in class in case people didn't get emails. That's one reason I need to see Taylor, because obviously her email isn't working because I got a Microsoft thing back that said they weren't able to deliver. So that's why I want to follow it up here. And then I know you'll find this hard to believe, but I've heard rumor that some students don't even check emails. Can you believe that? Okay. All right. But none of you. Okay. So let me follow up with what I sent before. Your course class key is what they call it for this course. This is the Cengage WebAssign class key. Even though I'm not going to use WebAssign, I think they require it to use this key, class key, in order to access the ebook, which you've paid for, which to me is ridiculous, okay? But that's how they operate their business. They're trying to get people to have to buy another package. But anyway, you've already paid for it. So here's that class key. Lawson.al, and then it's an 8-digit code, 2655 5068. Okay, does that agree with what I sent you in the email? Well, y'all don't know you have already. No, I didn't say that. Okay. Has anyone run into any difficulty with accessing anything on Cengage, like the ebook or anything else like that? Okay. Early in the term, see, last year when they first started this thing, students couldn't access the ebook until we got them the code, so we were in a hurry to get them the code as soon as we could. And then this term, it seems like Cengage may have actually listened to us and said, look, students don't have the code yet, because, various things. So they gave a grace period. Now, I think the grace period is just about run out, so that's why I'm asking, has anyone had any difficulty accessing anything? Now, the other thing I'd like to ask you to do, whether you use this or not, go on it and check it out, because when they sent me the Math 113 pre-calculus trig key stuff that I asked them to set up, at the same time I asked them to set yours up, but this was weeks ago. Finally, one of the students came up and said, the stuff they sent is for Math 100. I said, what? And they had the right book, but assignments for the Math 100 course. Not the Math 113 course. So I sent them back, and we had to go back and forth on to clarify things and stuff, and it was just all right there in front of them. Oops, okay, sorry, we did make a mistake. Okay, but it took weeks, and that's one reason yours was late getting to me, because they held up doing anything else until they got that straightened out. So sorry about that. So anyway. Check it out, and if you find out it's the wrong book or wrong chapters or wrong assignments or anything else, whether you use them or not, just let me know so I can get them to correct it. But they did correct it for the other class without any problem. So just wanted to let you know all is not wonderful in Cengage land, in case you thought it was. Okay, any questions? Sorry about all that delay. Here we have example 8. We're simplifying the derivative of a quotient, okay? Now, we're doing the chain rule. So my question to you is, how would you like to proceed with this? Would you like to use the quotient rule or try something else? Any of you have any preference? Okay. A lot of silence. Okay. Now, first and foremost, whether you use quotient rule or anything else, I would definitely not try to take a derivative of this thing in that form. How would you choose to rewrite it? And that may answer my question of how you want to proceed. How would you rewrite this? I don't like trying to take a derivative of a radical. Just aren't any rules for that. And I love rules, of course. Say again? A little louder. Okay. I didn't understand.
2x.
Okay, do x. Is that what you said? Oh, 2x. Okay. That's certainly going to be part of the derivative. I think I know where it came from. Inside there, right? Okay. And
what you want to do is change the radical to the 1/3 power.
to a what?
Change the radical to the 1/3 power.
Yeah, a power? Is that what you're...
X over x squared plus 4 to the 1/3.
Excellent, excellent. So what Bill is saying, rewrite this as x over x squared plus 4 to the 1/3 power. Okay. Now the fact, since you did it that way, would indicate to me you're probably leaning toward the quotient rule. Are you? All right. We got some hard workers on our hands. That's fine, okay? How would the quotient rule work here? You tell me. So having written that change, f prime of x would then be, how does quotient rule go? Okay, so low, is that what you're saying? X squared plus 4 to the 1/3, that's low, times d high is 1. Okay, very good. Next, minus x, that's high. Now we need the derivative of low. And I think this is where your 2x is coming from. What's the derivative of low? 1/3 x squared plus 4 to the what?
1/3 minus 3/3 2/3.
Right, which would be negative 2/3 power times 2x. There's your 2x, right? All right. All over x squared plus 4 to the 2/3. Perfect. Okay? Now, let's clean that up a little bit. For now, we'll leave this x squared plus 4 to the 1/3 as it is. Okay? Minus. Now, let's combine what we got. We got an x here and a 2x over there, so that will multiply to be a 2x squared. Okay? Over, this is all the second term here, the 3 is in the denominator, and the x squared plus 4 to the 2/3 power is in a denominator. In the numerator. And all that's divided by x squared plus 4 to the 2/3 power. Okay. Kind of a mess, but a doable mess. Everything's covered all the horizontal surfaces here pretty much. Okay, so what are we going to do to clean up a little bit of this mess? Now, back when algebra, I guess, somewhere back there, this would have been called, they like to call it a complex fraction. I don't like that term because complex to me denotes imaginary stuff in there somewhere. And this is all real. So I like to call it a complicated fraction, except students say, well, all fractions are complicated. So that probably isn't a good term either. So I guess complex is as good as you got. And what you do then is, if you have denominators in either the numerator or the denominator, that's what makes it complex, you might say, let's multiply everything in the numerator and the denominator by whatever the least common denominator is. Well, if all this is the only one with the denominator, so that's the only denominator. Let's multiply numerator and denominator by that. Okay? So here we'll multiply by 3x squared plus 4 to the 2/3 power. Okay? And we'll do it over here too. 3 times x squared plus 4 to the 2/3 power. And we'll do it down here, 3 times x squared plus 4 to the 2/3 power. Okay? I guess I have that in there. Now, one thing gets pretty much a lot simpler. This part here, you're multiplying this thing to 2/3 and that times that to the 1/3, same base, different exponents. What do we do? Multiplying the same base, different exponents. Keep the base, x squared, and add the exponents. And 2/3 plus 1/3 is 1. All right, that comes out nicely. All right, over here, this comes out pretty nicely too. That just disappears. Ha, that's why we multiplied by it. So that'll be minus a 2x squared. Correct so far? All right. Down in the denominator is not quite as pretty. The 3 can come out. Okay, that'll be fine. But then you have an x squared plus 4 to the 4/3 power. Same deal. Except it's a bigger exponent. It doesn't. You don't lose the exponent. Okay. All right. Now for this part, let's distribute. Since we lost the radical part, we can distribute here. And what does that give us? 3x squared 12 minus 2x squared. Well, that comes out to x squared plus 12. All right, that simplified some, and that may be about as simple as we can do it. So let's see how that answer looks. X squared plus 12 over 3. How about this? Let's write this as x squared plus, ooh, no, that won't work, does it? Yeah. Yeah, well, nah. I don't think it'll help us any. X squared plus 4, that's to the 3/3 power times x squared plus 4 to the 1/3 power. I was going to see if that would make things any better. And it sure, no, it doesn't. It held a little bit of promise, but it doesn't. So I'm not sure that's any better. You could have left it to the 4/3. Now, very complicated, but if you go back to the form that we just had before I split that out, x squared plus 12 over 3 times x squared plus 4 to the 4/3 power, that is the answer. This numerator over that denominator, before I tried to, I thought maybe I could simplify things. I couldn't. Okay? Always try. Worth an effort. Okay? But so there's our answer. I'll write it a little neater. X squared plus 12 over 3 times x squared plus 4 to the 4/3. All right. And Frederick decided to show you there. That's good. Okay. All right. Welcome. All right. And do you go by Frederick or Fred or Freddie or what? What do you prefer?
I guess
Fred? Okay. because I thought at first, yeah, and then I saw you sign your paper something else, and I thought, well, what does he want to go by? All right, so that's doing this using the quotient method. Does anyone want to see another possibility? Yes.
Before you move on, can I ask a question about that?
Sure. Oh, absolutely. Anytime.
All right. When you're working the quotient rule,
Yeah.
and you low d high minus high d low, and you take the derivative of the denominator, which is x squared plus 4, to the 1/3 power.
Right.
You're taking that derivative.
Right.
And so you multiply the exponent by the base, and then lower the exponent by 1, so you get the negative 2/3.
Right.
And then I know that's the chain rule, you're multiplying it by the derivative of the inside, right?
Right. Exactly.
So why, I'm just trying to remember why you have to use the chain rule. Why can't you just use the power rule, multiply the exponent by the base, lower the exponent by 1? If it were another exponent, is it because you've got the x squared plus 4?
Yeah, because that's a function inside a function. It's a composite function. You got the whatever the root function is, and then a function that that's being done to. And the chain rule says take the derivative of the outer and then take the derivative of the inner.
Okay. So
if that had just been an x cubed there or something like that, or x to the 5th power, then that's all you have to do. In fact, you could have taken that on the outside with the exponent out there. If that had just been an x or something like that, then you wouldn't have to do a thing more.
So if it's a function raised to a power,
Yeah.
or whatever, and a function is if it was I'm trying to figure out just to make sure I understand what it has to be raised to the power.
Right.
If it's a function as opposed to a constant.
Right. Yeah. Well, if it was a constant raised to the power, that's just a constant.
Right.
If it's just x, or say x plus 3, or x minus 17, or something like that, the chain rule doesn't do you anything for you because the derivative of the inside is just 1.
Okay.
So guess what? We've always been doing the chain rule, but before this we didn't have anything there but 1. Okay. But now we just have to take that extra step. If whatever's inside there, if that was just x to the 2/3 in the power rule, it's all you do.
Yeah.
And if it was x plus 1 to it, that's all you do. Because the chain rule doesn't produce anything else. But as soon as you put something else in there that has a derivative other than 1, then you have to include that.
Okay.
Yeah. All right, good question. Guy in my differential equation class, I wish he'd have asked those questions. I didn't have him in my course, but he still has trouble with the chain rule, and I think that's key to it. When do you do and when do you not? Okay. Now, I don't know if it's worth it doing this again, but here would have been my way of doing this because I'm just a bit lazy, very lazy. Okay. I would have rewritten this like this: x times x squared plus 4 to the what? Negative 1/3 power. And then I'd use the product rule because it doesn't have as many steps in it. Okay? Yeah, it still has steps, but not quite as many. So the product rule would give you what? How does that go? Oh, well, that's the function. Now let's do f prime of x. What would that be?
1 times
Okay.
negative 1/3.
Negative 1/3.
2x.
X squared plus 4 to the negative 4/3 power times your favorite, 2x. Okay, that's the first. No, wait. You just double did me there, didn't you? Trying to lead me astray. Shame. Okay, wait. Back off a minute here. Did I erase too much? I don't think so. Okay. Sorry. If you take derivative of the first, which you did, then it's just the second, right? Okay, so that just be x squared plus 4 to the negative 1/3, then times, or plus, I'm sorry. It's the derivative of the first times the second, that's what we just did, plus help me, somebody. The first times the derivative of the second, right? In whichever order you want to do it, okay? So this will be a negative 1/3. This is what you were doing, but you took derivatives of both of them, okay? Actually, you're in good company. Leibniz did that, his first paper on it. And then someone said, this doesn't work. He said, whoops, and went back and changed it, okay? And this would be then times what? You were saying before? X squared plus 4 to the negative 4/3 times 2x. I think I got enough parentheses there. Now, to keep it from being too big of a mess, I'm going to erase all the rest of it. Is that okay? And that'll also prevent me from seeing what the answer is and making it come out the same way. No, I'm going to leave that answer down there, okay? But that's only so we can compare later. This must look really weird at home. But things just start. Ooh, I just did it. I erased the answer. I didn't mean to. You might say, why didn't he just erase the whole screen and start over? I was just being stubborn. I think that's all I erased. Okay. So here's your derivative. So what does that look like in real life? 1 over x squared plus 4 to the 1/3 plus, and here we have our, well, actually that's a minus, isn't it? Because there's a minus in there. So that's a minus 2x squared over 3 times x squared plus 4 to the 4/3. And that is a perfectly correct answer right there. Okay? But because it's like 1/6 and plus 2/3, they don't quite have the same denominator, so let's see if we can get least common denominators, because it's just a subtraction. What would be your least common denominator? That one right there with it. 3x squared plus 4 to the 4/3. That's good, because that was our denominator before. See, I told you I had left it there for a reason. So that means you would have to multiply to get this out of this one. We have to multiply by 3 here, which means a 3 up there, and then by x to the 4th, this thing here to the 3/3, right? To get this to look like that, so that would be x squared plus 4 to the 3/3, which is 1. And now we have, that becomes a 4/3 because we multiplied by 3/3. So you add those exponents. Now you have common denominators, and here's your 3x squared plus 12 minus 2x squared, which of course is equal to x squared plus 12 over 3 times x squared plus 4 to the 4/3, which is exactly what we got before. And at least in my mind, there are fewer steps. Now, maybe if you added them all together, you'd find out they were, but, I don't have to remember low D high minus high D low over low low. That's just too much for me to have to say. This is just first time derivative of the second plus direct second time derivative of the first. To me, a little easier to remember, and I think a little easier to operate with. Fractions are always a pain in the neck. Okay, not always. They're our favorite friends. Okay, Taylor, right? Okay. Don't mean to interrupt class with it, but I just wanted to show you this. Okay. I can't keep this covered. Have somebody. I don't have any information. I use recycled paper. I tried sending you something through Whiteboard that said through. You been getting emails? Huh? Is it? Okay. Would you mind going by records office and telling them? Maybe they gave you the wrong. I don't know what the deal is, but something in the system's wrong. Okay. And if they can't fix it, then let me know they can't. I'll get in touch with somebody else. I don't know. Why don't you go and give me the correct email, and I'll see if they can put that in the system. Sorry to interrupt class like this, but I was afraid. I'd bolt out the door as soon as the class was over with, and I'd forget to say something. It'd be her fault, of course, not that I forgot. You know how that is. Thank you. In other words, you don't check your Lawson email.
No, I do, but since, I thought you were working out first, Lawson, like you were trying to send me a Lawson email.
Yeah, well, but evidently the Lawson one's not working.
Okay.
Yeah, so, and I thought you were going to give me the corrected Lawson one, but, okay. But I'll see what I can find out here. All right, thanks. Okay, so, guess what, folks? You've already paid your money, so take your choice which way you like it. Product rule, quotient rule, it doesn't matter. Once we got the chain rule into my tool belt, I seldom go back to the product rule. The quotient rule. I always use the product rule. I was going to tell you that earlier, but we didn't know the chain rule yet. So, but that's what I do now. Why did they do it in the book? They did it the quotient rule, didn't they? Sorry. So if you like that better, that's what they like too. So go for it, folks. All right. Let's move on to example. Oh, let's see how they do it. Sorry, I forgot this was on here. That took way too long, didn't it? Sorry about that. Okay. So what they do is they rewrite it as just like Bill suggested, and putting that as x squared plus 4 to the 1/3 in the denominator, and then go to town with the quotient rule. Sorry about that. I probably shouldn't have polluted your mind with the thought that you could do something else, okay? And what they did is low, this low, D high, that's it, minus high, there it is, D low, there it is, with the chain rule, over low, okay, which is the denominator squared, okay? And then the rest of it is arithmetic. And isn't the calculus part so much easier and more fun than the arithmetic part? For sure, okay? So what they did here, if I can figure out what they did here, I'm not sure I would have approached it this way, but what they did, they factored out a 1/3 x squared plus 4 to the minus 2/3, because it showed up here, factored that out here, and then, of course, factoring this and dividing by it is also, so when you divide by 1/3, you get a 3. When you divide by this to the minus 2/3, you get that to the 3/3. This is certainly not how I do it, and then dividing that out there, you just left with a 1, okay, because they combined the 2x and the x. Man, okay, if you see that and it's, oh yeah, of course that's what they did, then more power to you, okay? Not how I would have done it. And anyway, that gives you x squared plus 12. They moved the 3 to the denominator, okay? X squared, They moved all that to the denominator. The 3 and this thing, and that gave them to the 4/3. And all they had was your numerator left, 3x squared plus 4 plus 12 minus 2x squared is x squared plus 12. Everything they did was right, skipping all the steps they wanted to make it look like it was short. Okay? However, you see it and you understand it. As long as your steps are right, your answer should be right. Okay? Make the wrong step and you made your partner have a sore toe. Okay, never mind. Let's go to example 9, which they show in here, which is surprising. And you can also go to larsoncalculus.com for an interactive version of this type of an example. How in the world would you do that? I can think of at least 3 different ways you can approach it. So whatever floats your boat. What do you understand best? How would you approach that? There's several ways to go. Power rule first, which would be y prime is equal to what?
Well, you want to get, take the derivative first times the second, and then plus derivative second times the first.
Okay.
And so, but you're going to leave the first and just go with the 2 times.
Okay.
The quantity 3x minus 1 over x squared plus 3.
Perfect. To the first power. Now chain rule that.
And then you're going to do the derivative of 3x minus 1 over x squared plus 3.
Okay.
And that would give you times, the first times. Okay, you would have x squared plus 3.
Yeah.
Derivative of 3x minus 1 over x squared plus 3 squared.
Okay. So x squared plus 3. Okay, you did your power rule 2 times what that. Now you're going to do times the derivative of this. So you're doing the chain rule on this one. And the derivative of this is, I take it that he was doing a quotient rule called Bill loves the quotient rule. Okay. It's 2x squared plus 3. Low. D high. What was D high? 3 minus 3x minus 1 high times 2x d low over what Bill was saying, x squared plus 3 squared. Okay. Is that what I was understanding? Okay. Okay. Yeah, that makes sense. You did the power rule on this, which is 2 times this, raised to the first power. But then you got to do the derivative of this, because that isn't just an x anymore, okay? So then the derivative of this, since it's a quotient, is low d high minus high d low over low. Okay. That's a dumb way to say it, isn't it? But, you know, it works for me. Okay. Now, the rest, that's an answer. That's a perfectly good answer. The thing is, the rest is just to make it look nicer. Okay? So let's see what we've got. The denominator now is a cubed. Okay? So that's x squared plus 3 cubed. Right? Because you have 1 here and 2 there, so that's 3 of them total. So let's see what we got. Yuck. All right. This will be a 6x minus 2 here times a 3x squared plus 9 here minus, and we got the same thing here again, 6x minus 2. This probably isn't the easiest way to do it, but in my simple mind, it works. I don't like it much. I'm going to unsimplify this a little bit. What were you going to say?
Never mind.
You may have got the same idea I did. Okay. Okay. It has a 2 here and a 2x there, so that's going to be a 4x times 3x minus 1 squared. Is that what you were thinking? Probably not. You were thinking much more logically than I was. Okay. I was just trying to write less, so that was the least amount of writing I could do. It doesn't really help us any, though, does it? Okay. So let's... All right. For this numerator, the first part of it anyway, what does that give us? Seems like I should. Okay. 18x squared. And then let's not spell 4 right. Let's do the inner next. That's x cubed, yeah. Someone said that. Who told me wrong? Okay. All right. All right. 18x cubed. What's next? Minus 6x squared. Now let's do the outer. (54x) and finally minus 18. Okay, minus 4x, I can't write, times, let's square that, and what would that be? Square that binomial. Help me, somebody. Help me, please. Squared 3x. 9x squared. Twice the product. Minus 6x plus 1. Okay. Now, let's go on and do this. So it'll be a minus 36x cubed plus 24x squared minus 4x. Okay. That will be where that takes over. I just got tired of writing, and I don't have much room. All this is over x squared plus 3 cubed, I hope. All right, let's simplify now. If I can read. That's a 36. Right? 18 minus 36, that would be a minus 18x cubed. Let me keep the minus sign with it for now. We may pull it out later. Okay. Plus, is that an 18 again? Someone's going to say, I was trying to tell you there was an easy way to do this. Okay. Save it. Okay. This will be plus 50. I don't think so. Okay. And minus 18. Goodness, everything's divisible by 18 except 50. What a shame. Okay. X squared plus 3 cubed. Now I know I can factor out some stuff. A 2, for instance. And that's about all, isn't it? 2 times, let's pull out a minus 2 and make it a 9x cubed plus 9x squared. Oops, minus 9x squared. If I pull out a minus sign. Okay. Minus 9x squared minus 25x plus 9 over x squared plus 3 cubed. Now, if anyone can convince me that there's an x squared plus 3 factor somewhere buried in there, I'll thank you very much, but I have a feeling there's not. If you group the first 2, you don't get anything that's worthwhile out of the second 2. Oh, shame on them. They didn't carry it as far as I did. It's probably what you were suggesting, wasn't it? Leave the factor of 2 times 3x minus 1. So you had 1 here, and you had another one there. So leave that on the outside. Okay. And then, okay. So what they did, they just didn't multiply by this. They just took this term here and subtracted that term from it. So I think we got the same answer. Like I said, there's probably a dozen ways you can express this answer. That's 2 times 3x minus 1. Yeah. And that would give you a 3x squared plus 9 minus 18. Nope, there's some discrepancy between the two answers, but I think there's probably just some dumb mistake I made somewhere in here that created it. But that's exactly how they did it. Let's just see if this part works out the same. Yeah. Everything, that first line is perfectly correct. Maybe I made a mistake somewhere in the second line, but we approached it differently. But here's the deal. That wasn't the only way you could do the problem. It certainly was one way. My temptation, again, not liking product rule, quotient rule that much, I was real tempted to write this as 3x minus 1 squared times x. Let's see. No, I think I'd leave the first part alone and then just write the second part, derivative of that as a product rule, and do it that way. But I'm not going to pollute your minds anymore against the quotient rule. Again, I would have I would have left the first part the same, 2 times this, but then rather than doing the quotient rule here, do 3x minus 1 times x squared plus 3 to the minus 1. And seeing if that would have been a little bit easier to do. Not saying it probably would have been almost the same number of steps, but I can almost guarantee you I wouldn't have made whatever stupid mistake I might have made in here because there were just so many more opportunities to do it. But whatever floats your boat. Again, there's several ways you can approach a problem like that. The best way is that first step is a power rule. 2 times that to the first power. And then after that, you can either use the quotient rule or the product rule when you write it like that. That's just the second part. The first part was still just like this. Okay? But then taking the derivative of that is the deviation there. Then you have your fractions to deal with, and if you don't like fractions, you might like this better. Okay. Now, what they'll do at the LarsonCalculus.com, I'm not sure, but let's see how they explain it. I think we've just seen how they do. But they're going to do a power rule first. 2 times 3x minus 1 over x squared plus 3 to the first power. That's the first part. Now times the derivative of what's inside there. This is the chain rule part. Okay? But the chain rule then, that last derivative is a quotient rule. So leave the first part just like it is. They just wrote 2 up here right from there, but otherwise that's the same. And then they did a low d high minus high d low over low squared. Okay? And from that point, they left this factor, and then they multiplied this, became a 3x squared plus 9 minus 6x squared plus 2x. And then when they combine those like terms there, leaving the first part just like it was, then they had a minus 3x squared plus 2x plus 9. And then left the denominator like that, without even attempting to see if there may be a factor. And I don't think there could possibly be a factor of that in there. So Now, even in this form, I would have been real tempted to bring the minus out here and leave this as a 3x squared minus 2x minus 9. But you don't have to do that. So I just usually don't like leading a quadratic with a minus sign if I can help it. That's just a personal preference. All right, any questions on that? Lots of ways to do it. Just do it right here. Okay. I don't want to have to figure out what you did wrong. I want to just check it yes and go on. Okay. Trigonometric functions and the chain rule. All right. Now, just a reminder here. Remember what d by dx of sine u is? If that was d by dx of sine x, what would that be? All right. It was a week ago at least. Okay. What? Cosine x. But with a u in there, that may be a function of x too, so it's cosine u du. Derivative of the outermost function, that's the sine function, then follow it by the derivative of the innermost function, u prime, du dx. So everything just like you would expect, I hope, except this may be a function of x. It's not x, so you can't just assume it is a constant or anything else, so we do a u prime at the end. So derivative of cosine is minus sine u du. I like to think of it that way, but that's only okay. And this would be secant squared x, secant squared u du. This would be minus cosecant squared u du. Secant tangent times u prime, and minus cosecant cotangent. Again, my little thing to remember, the regular function, sine, tan, secant, those are positive when you take a derivative. The cofunctions of them, they all wind up being negative. If you can just remember one set, just remember to put the minus on the other. And even better than that, look it up. You know, don't trust memory. Look it up. But you always have to do a du if there's something else out there. Okay? Well, what else could be out there? Well, here's one. What is the derivative of sine of 2x? Anybody?
Cosine of 2x times 2.
Exactly. Cosine of 2x times derivative of 2x, which is 2. 2 cosine 2x. Most of the time it's helpful to put it there. The reason it's not a good idea to leave it here is someone might think, especially if you left off this set of parentheses, that 2x was times 2. No, the 2 is times the cosine. And a lot of people will do this anyway. They'll do the d by in front. You know, that's what I think at the very first you were doing the derivative of the inside first, which a lot of people like to do that first, and just don't forget to take the derivative of the outer part too. So you can do it either way. It's a product. Okay, how about this one? What would that be? Anybody? What? Derivative of cosine is? Negative sine of x minus 1. And that's all, folks, because the derivative of the inside is just 1. You know, sort of like we were taking before. This one isn't much of a chain rule. You can think of it as 1, but that derivative of that thing is just 1. So it's just minus sine of x minus 1. Now, if any of you were wanting to use the sum angle formula for that and do it, please don't. Think something else. Yeah, you could do it, but let's not. Okay. How about this one? Derivative of tangent 3x. Anybody? Help me. My arm's getting tired. Somebody. Say again? Derivative of tangent. Secant squared 3x times 3. So then at the end, go on and pull that 3 out in front. 3 times secant squared 3x. Because just don't even want the possibility of someone to misinterpret that. So bring that to be up front. That's just for clarity's sake. Not that it's necessary or anything. It's just clarity. All right. Any questions on that? They did all the work for you. So, they're skipping a bunch here. They did all those others, thank you very much, but they're skipping 11, 12, and 13 here. So let's go back and do 11. All right. Oh, they'll talk about parentheses now and trigonometric functions. So here's one. Y is equal to, this is the a part of 11, cosine 3x squared. Okay. Now, if that's what you were given, and you said find the derivative, what would be your y prime? Anybody? Say again?
Use the power rule first.
Okay. And what would that give you?
2 times cosine of 3x.
Okay, now, okay. This isn't cosine squared. Okay. And that, I guess, is what they're getting at. If it's helpful, put your parentheses in here. Okay. It's not cosine squared. It's cosine of 3x squared. Okay. So the cosine is just by itself cosine. It's not squared or anything else. It's just its argument has the square in it. So what would that be? Derivative of cosine is? Minus sine of, that's an n, 3x squared. If you want to put parentheses in, you don't have to. Times what?
6x.
Times 6x. And then I would write this as minus 6x times the sine of 3x squared. It's up to you whether you put the parentheses in there or not, but the argument is 3x squared. The square does not go with the cosine or with the sine. It goes with the x. Okay. All right. Minus 6x sine 3x squared. Perfect. Okay. Any questions on that? Do you see what they're doing with it? Now here, very similar problem. Y is equal to, this is weird, cosine 3 times x squared. How in the world do you do that? In my little bitty little mind, I can't ever imagine having a real problem out in the real world that looked anything close to that. But in case you ever did, how would you do it? You got it. In fact, I think I would have just gone and said 2 cosine 3 times x. Yeah, or anything like that. Times 2x is fine. But you see, cosine 3 is just a number. That 3 is in what units? And if any of you say it doesn't have units, you'd be absolutely correct. But what am I getting at here? It doesn't have a... Say again? It doesn't have a power, but it doesn't have a degree symbol. If that was a degree symbol, that would be cosine of 3 degrees. Without the degree symbol, that's what? Cosine of 3 radians. If you ever see a trig function with just a number associated with it, never assume that's degrees unless you see the degree symbol. Always assume it's radians. So that'd be cosine of 3 radians. Just a number, okay? Just a number. So that's a coefficient times x squared, 2 times the coefficient times x, okay? And they probably, no, they wrote it this way, which is actually, there's a reason for it, 2x cosine 3. And the reason is that if I did not put that parentheses in there, you might think that was cosine 3x, which isn't, it's cosine 3 times x. So they bring everything in front of that. So it's constant, variable, constant, okay? But that is actually a good way to write the answer, okay? But how you write it isn't as important as that you get it right. If you left the parentheses in there, that's a perfectly fine way too. Here's the third one. Same set of lettering, cosine of 3x squared. What in the world would that be? Anybody? Oh, sorry. I realize I sloppy here. I left off my y prime in both cases here. Okay. What is y prime?
Negative sine of 3x squared
Negative sine of 3x squared.
times 6x.
Okay, say that again.
Times 6x. Wait. Okay, you should have been cosine of 9x squared.
That's how I think I would have started the problem. Cosine of 9x squared. It takes a lot of the guesswork out of it. Then this would be y prime would be
Negative sine of 9x squared times 18x.
times 18x. Okay. Which then I would have written as minus 18x sine of. And if you want to go back and write it the other way, you could 3x squared, since the original one was written there. But if you had gone through brute force like we were going to, minus sine of this, which is fine, that's what we lined up here, then you would have a double chain rule here. 2 times 3x, that would be 6x, times another 3, because you have to do the chain rule of the inside again. You first do the chain rule of that, and then do the chain rule of that, so that would be 6x times 3, root of that, and that would give you 8. So you could have done it that other way, but it gets wacko. So go on and straighten this out here, and it makes it so much easier. I like that way. I don't know if the book liked it that way, but I don't care what. No, they did. They rewrote it as cosine 9x squared. Good for them. Okay. The next one. Y is equal cosine squared x. And this, I think, is the one that Bill was starting to do before. What would that be? Y prime. What would that be? Help me, somebody. Anybody? Where would you start?
I'd start with a power rule.
Yeah, exactly. It's just that you got a function that's raised to a power, and that function is the cosine. Who cares? Power rule would be 2 times cosine x.
To the first power. So.
Yeah, to the first power. I wrote it there. You just don't see it. Okay. Times.
Derivative of the inside, which is negative sine.
Negative sine x. okay? And that would be minus 2 sine x cosine x. Now you want me to get really obtuse on you here? Does anyone recognize that as something recognizable? It's a double angle identity. That would be sine of 2x. So this also could be written as minus sine of 2x. Because the 2 is part of the answer. So let me get that out of there. But that's recalling stuff from trig class. That obviously doesn't pertain here at all, does it? At all. Okay. They didn't even bother to do that. Okay. So you don't need to know it right now. If you ever do know it, okay. How about this one? Y is equal to the square root of cosine x. Now, before I even attempt to do a derivative of that, what am I going to do first? Because if you happen not to remember, I don't like taking derivatives of radicals. Okay? I don't even like thinking about that concept. So what do? Anybody? Give me a hint. Help me, somebody. Drowning up here. Second? Yes. Okay, is this how you say it? Cosine x to the 1/2 power? Is that what you said? That's perfectly fine. Another way you could write it, though it's no better, no worse, of cosine. Those mean the same things, by the way, okay? Just to get it down. Okay. So now that we've got that done, I think I'm going to have to erase some stuff. Is that okay? Have you got the other part done? The book didn't even do that. I'll just erase that, and we haven't lost the thing, have we? Okay. Now we'll do y prime. And what would that be? Either one of those that strike your fancy. Okay, did I hear 1/2 cosine of to the what? Cosine x. That's okay. Well, I'll need to put that in parentheses and put what outside of it? Anybody? Help me.
Lower the exponent by 1.
Yes, so it's minus 1/2. Then I've got to chain rule. What's that? Derivative of the interior function, which is, yes, negative sine x. All right. All right, what will that look like in real life? That will be a minus. The numerator part is the sine x. The denominator part is a 2 down there from the 1/2 and a square root of cosine x. If you go back to the original way of doing it. That's one way to write it. You could have left it to the 1/2 power in the denominator, or you could have put it in the numerator to the negative 1/2 power, a lot like we first had. What way do they leave it here? Not that it's anything special. They did minus sine x over 2. Yeah, amazing. I get it the same way they did. Something's wrong with my head. I don't know what it is. Okay. Now, what we sort of did with this one way we worked it was using the chain rule twice. We're going to do that, repeated application of the chain rule. That's going to be example 12. Anyone have questions on 11 before we move to 12? All right. And again, this one isn't in the slide set, so we're going to use this slide here. Okay. F of t is equal to sine cubed of 4t. Okay? And the question is, what is f prime of t? Where would you begin? Now, they started by writing it in a different way. I'm not particularly keen on that because it doesn't really clarify anything for me, but if it does for you, do it by all means. Okay? So what would you do to find that derivative? Okay, you got 3 times the sine. Okay. Doing too much at once. Okay. What is your outermost function here? Nope. The cubing function. Then the innermost from that is your sine function, and then the innermost from that is your 4t. Okay? So this is a 3-layered composite function. Okay? Composition of 3 functions together. So you started off right by dealing with the cube. Stick with that. Just the cube. So that would be 3 times perfect. 3 times sine squared 4t. Okay. You did the power rule there. Now what's the next part? Second? Okay. Okay, I agree we moved to the sine yet, but you see we kept the sine in place because you're dealing with the cubic part first. Oh, yeah, cubic part first. Now we deal with the next level inward, which is the sine function. What's the derivative of sine? Cosine. And that would be cosine 4t. Don't mess around with the squared anymore. You've already dealt with the cubing function. That was dealt with in the first part. Now we're dealing with the inner function, which is sine of 4t. Its derivative is cosine 4t. But you have yet another inner more function, and what is that? That's the 4. Okay, the 4t and its derivative is 4, which you were going right for the jugular there to begin with, but you got to do it one step at a time. Do the cubing function first, 3 times u squared, and that's what that gave you. Then times the derivative of u, times the derivative, but u is a function of v, and then do the derivative of v. So pulling all that together, the 3 and the 4 would give you 12 sine squared 4t cosine 4t. And we could get really bizarre here and come up with a double angle there, but it would be really nasty, so let's not mess with it. I think that's how they leave it. Yeah. 4 sine squared 4t cosine 12 sine squared 4t cosine 4t. Perfect. All right. Now let's go to 13. How are we doing on time? Y'all are going to keep me from going too long, aren't you? Yeah, we got plenty of time, don't we? Okay. All right, so let's do 13. Okay. It says find an equation of the tangent line. So what we're looking for find an equation of a tangent line of to the graph of, and is the function. F of x is equal to 2 sine x. I can't write. Plus cosine 2x. Okay? At the point pi 1. All right. Now, before I even proceed, I want to make sure they're not sending me off on some wild turkey chase, goose chase. Okay? Is this point even on that function? Well, we plug in the pi for the x part. And what does that give? Sine of pi is 0. Good. Y'all are great at that. Okay. And 2 times 0, of course, is 0. Plus cosine of 2 times x. Well, x is pi. What is cosine of 2 pi? 1. Very good. Okay. And 0 plus 1 is 1. Yes. When my x is pi, my y, which is your f of x, is 1. Good. So we can do this. Find the equation of a tangent line. Well, what do I need to know the equation of a line? I sort of need 2 bits of information. If I had 2 points, no sweat, I could do that. We have 1 point. What else would I need besides the point to write an equation of a tangent line? A slope. If only we knew the slope of that thing. Well, what is the slope of a function? What's the title of this chapter? Differentiation. Yes, it's your y prime, or f prime of x. Okay, and what is f prime of x? Help me, somebody. What's f prime? Not that hard, is it? Anybody? Derivatives. Okay, I'll write the 2 down. Okay, what's the derivative of sine? Cosine x. Plus, let's not even write the plus, okay? Because, what is the rest of it? Second? Minus sine 2x. Is that what I heard? Was that all I heard or something else?
Times 2.
Times 2, yes. Okay. My hearing's bad. Okay. So there's your first derivative of that function. Well, that's going to be the slope at any point x. What point are we interested in? At pi. And that would be 2 times the cosine of pi minus 2 times the sine of 2 pi, right? What's the cosine of pi? -1 times 2 would be -2. Sine of 2 pi? 0. So f prime would be that. So this happens to be the slope at pi. All right. So now that we know a point and the slope, how can we get an equation of a tangent line? Okay, to what?
Well, put pi over 1 and then just do -2 slope.
Okay.
I mean, pi, put point pi 1 and then -2 slope.
Okay. Okay. If this is what you're saying, I'm okay with it.
I was thinking graphically.
Yeah, oh yeah, right. Okay, yeah, he was going to graph it for me. Okay, got it. I want an equation. I don't want the graph of an equation. I want the equation.
You could do y minus 1 equals -2 x minus 1.
Perfect. That's a good old point-slope formula, since we have a point and we know the slope. Y minus y1 is equal to the slope m times x minus x1. That's it. And the x1 is pi and the y1 is 1, so we got it. Let's multiply through and see what we get. Y minus 1 is equal to negative 2x plus 2 pi, and then let's add 1 to both sides, and you have y equal minus 2x plus 2 pi plus 1. There's your y-intercept is 2 pi plus 1, slope is negative 2. Okay? Let's see how they did. Y is equal to minus 2x plus, they did 1 plus 2 pi. It doesn't matter. Okay. That's it. Okay? First, the negative slope, and then the slope of the tangent line they show there. Good for them. I didn't want to graph that anyway. If you don't have a book, or a graphing calculator, or something else, you can do this. This is how that function we graph like this. And at pi, you're on the downhill slope there, and sure enough, slope of minus 2. And the y-intercept, if you had extended this on upward, it would have crossed about 7.28 or something up there, way up there. And sure enough, that's what it looks like. Okay, any questions on that? Oh, we didn't finish it, did we? Find the equation of the tangent line to the graph of f, blah, 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 at the point, blah. Then determine all the values of x on the interval 0 to 2 pi at which the graph of f has a horizontal tangent. How will we do that? Has a horizontal tangent. Have we got to go back and reinvent a wheel somewhere? What can we do? Tell me something about a horizontal tangent. Slope is 0. And what was the slope? The first derivative. Make that equal 0. So let's just write that equation down. 2 times the cosine x minus 2 times the sine of 2x is equal to 0. Okay? Anyone want to guess the first thing I'm going to do? Divide by 2. Done. Okay? Doesn't seem fair, but it is. It's an equation. You can divide both sides by 2, and 0 divided by 2 is 0. So that leaves me a cosine x minus, but rather than writing that as sine 2x, I want to write that as its equivalence in terms of x alone, arguments of x. And we had it maybe 15, 30 minutes ago, which is a long time. Anyone remember what that was? Sine of 2x is? All right. Do you remember your sine of, say, a plus b? I can't write. Anyone remember how that goes? Sine a cosine b plus cosine a sine b. Now, why would I be interested in that? Well, what if a was equal to b? Then this would be sine of 2a, wouldn't it? And what would that be? Sine a cosine a plus cosine a sine a, right? Which would be, doesn't matter order, 2 sine a cosine A. So this would be 2 sine x cosine x. That's equal to 0. Now, why did I bother to do that? What can you do now that you couldn't up there? Factor. And what can you factor out? A cosine x. And that leaves you with a 1 minus 2 sine x. And that product is equal to 0. What does that tell you? Product of two entities is 0. That tells you something about one of those two entities.
Set both of them equal to 0.
Yes. One or the other of those, or both, has to be equal to 0. So either cosine x equals 0, or 1 minus 2 sine x is equal to 0. I probably should have erased some stuff somewhere here. So first tell me, what values of x will make cosine equal 0 between 0 and 2 pi? We're only interested in those. What value between 0 and 2 pi is cosine x equals 0? Pi halves and 3 half pi's. Okay. The half pi's, that's where cosine is equal to 0. Now the other one's going to take a little more work. So I think what I'll do is erase this stuff up here that y'all know now by heart, and you'll never forget for the rest of your life. Okay? All right. And let's do the second one up here. 1 minus 2 sine x is equal to 0. I don't know if you remember how to do this. It's pretty straightforward. When you have a trig function in the middle of an equation, first solve for the trig function, then solve for the variable. So let's first solve for sine x. What would you do? Help me, somebody. Right. I'm going to write it this way. 2 sine x is equal to 1. Is that okay? I added 2 sine x to both sides. And I wanted to reverse sides. And now what? Again, solve for sine. Divide both sides by 2. Okay. Done. Now, at what values between 0 and 2 pi is sine x equal to 1/2? Starting out in the first quadrant, where is sine x equal 1/2? You hit some value here in the first quadrant, where is 1/2? What value is that? Pi over, no, that's root 2 over 2. Yeah, sine of pi fourths, sine of pi fourths is root 2 over 2. Sine of what?
Pi over 3.
Pi over, what did you say?
I said pi over 3, but it could be pi over
6, yeah. Pi over 2 is pi halves, that would be 1 there. So yeah, that would be x equal pi 6. Okay, now that's here, it's 1/2. Where else will the sine be 1/2? Over in the second quadrant. It's 1/2 again, isn't it? Well, down here it's negatives. So the only other place would be in the second quadrant. And where would that be? Pi 6 short of 0, pi halves. Pi is here. Pi 6 short of that is 5 pi 6. So that would be 5 pi 6. All right, so those 4 values. These 2 and these 2. Let's see if the reality here sets in. All right, somewhere here. So there is the pi 6. There was your pi halves here. Another horizontal tangent. This was your 5/6 pi, and then down here was your 3/2 pi. So sure enough, 4 places for the first derivative is 0. Pi 6, pi halves, 5/6 pi, 3/2. Thank you for drawing the graph for me. I didn't want to draw that. Okay. Any questions? See how to do that. Remember, horizontal tangents, slopes are 0. If you have the first derivative, set it equal to 0. All right, let's move on to these. The summary of the differentiation rules. And boy, some of these are so old hat. Why do they even bother writing that? Derivative of a constant is what? 0. Derivative of x to the n is? Help me, somebody.
N times x times
To n minus 1. Perfect. How about derivative of cu? Constant multiple rule. Help me. Anybody? Okay, how about if that was a cx? Derivative of cx would be c. That's yes in Spanish. Okay. Now, since that's not an x, it's a u, it's c times derivative of u, which would be u prime. Okay? How about somewhere difference rule? D by dx of, I love saying that, u plus or minus v. Not that hard. Somebody. Earth to class, come in, please. U prime, can I start it? Plus or minus?
V prime.
V prime, perfect. All right. Product rule. Oh boy, one of our favorites. What's that? D by dx of u times v. Several ways you could say it. Pick one. Just say it. Okay. U times v prime plus v times v prime. D by dx of u divided by v. vu prime minus vu prime, uv prime, sorry, over v squared. Perfect. Okay. D by dx of f of u.
F prime of u
Times u prime. Got it. Okay. The general power rule as opposed to the corporal power rule. No, never mind. What would that be? D by dx of u to the n. Starts off a lot similar to that one. What would it be? N times u to the n minus 1 times du, u prime. You're absolutely right. That was just like that sine cubed. Remember? We did 3 sine squared, that's n times sine to the n minus 1, then derivative of sine. But then we still had another chain rule in there and did that. Perfect. Oh, and what's that? D by dx of sine x. Cosine x, d by dx of cosine x is minus sine x. Tangent would be? Second, secant squared. Cotangent would be negative cosecant squared secant would be secant x tangent x, and cosecant would be minus cosecant cosat. Got it. And if those were used, then you'd have the du after all those. Well, they did them all with u's, except that one, and then this one put x's back in. I guess they were trying to be nice to you. I don't know. Never have done it before, have they? Okay, that ends 2.4. Homework exercises here include any of the odds 3 through 7. They're all at Calc Chat. 3's at Calc View. Any of the odds 9 through 33. They're all at Calc Chat. 9's at Calc View. Any of the odds 35 to 53. They're all at Calc Chat. 37's at Calc View. Any of the odds 55 to 59. They're all at Calc Chat. Do 61 is at Calc Chat. Do any of the odds 63 to 69, they're all at Calc Chat. Do any of the odds 71 to 77, they're all at Calc Chat. 75's at Calc View. There's some famous curves here, okay? 79, okay? Then there's 81. They're both at Calc Chat. Any of the odds 83 to 87, they're all at Calc Chat. Do either 81 or 89 or 91, they're both at Calc Chat. And then if you can explore doing, if you'd like, 93, if you'd like, and 95, if you'd like. And you can think about doing 97 if you would like. It should be pretty straightforward. Okay? 99. All these should be at Calc Chat. 101. Actually, I would say you pick of the ones you want to do any of the odds 101 through I'd say through 109. Okay, you may do more than one of those, or they should all be at Calc Chat. There's another one you could think about doing, 111, and 113 would be pretty good to look at too. Either 115 or 117, they're all both at Calc Chat. And then there's 119, you can do that one if you would like. And there's just a couple of true false, 121 and 123. They should both be at Calc Chat. You can do anything you want to with the Putnam Challenge. I'm not going to do it. Now, I think we're out of time, probably way past out of time. So we'll pick up next time with 2.5. Any questions? Good deal. And I will try to have your test ready for you next time so you can have something to do this weekend, okay? I know you would be very disappointed if you had the whole weekend to spend with no test to work on. Which means, of course, I need the first test in because you're going to be getting the second test as in Wednesday. And I don't want you making the same mistakes again on the second test if you made them on the first test, because I don't want to have to correct them twice, okay? So get your first one in so I can get it graded so you can see what you missed, okay? Make it life easy on me. That's your purpose in life, right? Okay. Good deal. Okay. I'm going to